And it's probably hanging in there because we're adiabatically filling it really, really slowly. She blew at the bottom. Oh, that was worth the wait. This morning I came into the lab, went up to the 4th floor, and I got some dry ice. We have probably a couple of 100 pounds of it up there. We use it all the time in chemistry. Why is dry ice actually used to transport these vaccines? Because after a few hours, you'd have your vaccine vials floating in water. The labels would peel off. It would not be a good thing. But here, as time goes on, the only thing that happens is you make gaseous carbon dioxide and you cool everything down to something approaching minus 109 degrees Fahrenheit. I took some food coloring and put it in a beaker of warm water, and I'm just going to drop in some of these dry ice. It looks like the water's boiling, but it's actually not. The dry ice is subliming directly from the solid state into the gas phase. Here's more dry ice. I've just put it in a beaker. It's been sitting there for maybe a half an hour. If you look inside the beaker, there's absolutely no liquid in there. I also got some ice from the 4th floor, and I put it in about a half an hour ago. And you can see that in the ice, there's the ice and there's water. So here's a fresh piece of dry ice, and I want you to compare that to the dry ice that I put in about 45 minutes ago. You can see that the dry ice is basically decreased in size by half at this point. And why is that? Well, that's because the CO2 is directly leaving the surface of the dry ice and going into the gas phase. And that's what's going on here. We have CO2 sublimating, actually coming off the surface of the dry ice, going into the water. It's a gas. It has a much lower density than water, so it's gonna bubble through. It's gonna cool the water down, and it's gonna make this fog that's coming off into the gas phase. You can see the water vapor freezing in here, and I'm maintaining that a layer of carbon dioxide is filling up this container. The bubbles are heavier than air, and they sink down onto the table. And you can see that there are a whole bunch of bubbles that stay suspended in the air. But it's not air, it's carbon dioxide. So the density of the bubbles is less than the density of the carbon dioxide, so they float. It's just like a helium balloon. And I think that's pretty cool.